Okay. Hello, everyone. I am Aviv, a researcher at UpDom, and today I'm going to talk to you about Android accessibility service malware and how to use it to perform credential stuffing attacks. Now, before we begin, raise your hand if you understood what I'm talking about. Great. So I'll explain first about credential stuffing attacks, what they are, then about accessibility service malware. Okay, so credential stuffing. Basically, we have something that's called a combo list. Combo lists are basically lists of username password combinations, hence combos. They are obtained from security breaches. For example, if a major website or a database or anything, a company gets hit, the attackers usually get the list of username passwords, and then they use it for their attack. Now, the point is, many users repeat their passwords over and over again. So if I'm stealing a database of hundreds, thousands, possibly millions of username password combos, if I try it on different services, different applications, I am virtually guaranteed to get hits. And each of these hits is a username password is an account that I can sell, or for malicious purposes. Not only sell, sometimes you can do things yourself with these accounts. So yeah, that's basically an easy way for an attacker to get money. Now, just to understand, if I'm searching Telegram for a combo list, you can get many of these for free. Now, if you're willing to pay money, you can get better combo lists. Of course, don't do this right. That's not good. You can then search for combo tools, which are tools that let you use these combo lists and check them in applications. Then you get a list of accounts that you can sell for money and become rich. Got it? Yeah, sure. Now, there are two types of credential stuffing attacks. The first type is a centralized attack, where you set up a server farm which has many emulators running, and each of these emulators will attempt to log in with our credentials from the combo list. Now, of course, many applications have built-in emulator detection, or sometimes simple anti-bot measures, such as if you're perhaps restricting the amount of connections from a single network address, then it will detect centralized credential stuffing pretty easily. The other type of credential stuffing, the more interesting one, is decentralized credential stuffing. You might have heard of it as a botnet. Basically, a lot of devices get infected, real devices, and then these devices run themselves the program that's checking the combo list. So basically, there's no way to know if an account logging in from a device is legitimate or not, because the device itself is legitimate. The problem is that you have to actually infect many devices in order for it to be effective. Okay? Now, the second thing I'm going to talk about is ATS malware. This will lead us to accessibility service malware, but first, what's an ATS malware? ATS is an acronym for automatic transfer system. That's basically a malware that steals your money, transfers your funds automatically without user interaction, hence automatic transfer system. Now, this thing is relatively new. There's a popular variant called Xenomorph. You might have heard of it. It's basically targeted lots of banking institutions and stolen a lot of money, and of course, that's bad. And that's in the past year alone. Now, basically what it does, how does ATS malware work? The first step is a device gets infected. That's usually done by social engineering. Like you get an email telling you, hey, install our app, it's good, or just browse to the App Store, and the Android Play Store actually has many malicious apps in it. So you might accidentally install a malicious app which contains the malware. When your device gets infected, the malware connects to its C2 server, asking it for directions, like what attacks to run, what apps to target, and then the server sends it back scripts to run, and it simply does its thing, whether it's stealing session cookies, or getting your two-factor authentication codes, or simply transferring your money back to its owner. A popular attack is called an overlay attack, which basically works like this. The user sees the left screen here, where they think they're actually transferring a small amount of money to themselves. Actually, what happens is the left screen is an overlay. The real screen happens underneath, it's the middle screen, where a larger amount of money is transferred to another user. And that's what happens in reality. And what happens is that the user is drained for money, and they really notice it later. Now, all of this can be done in ATS malware. The common technique for ATS malware in Android is an accessibility service. Now, what's an accessibility service? Accessibility service is actually a type of Android service. It exists to give mostly disabled people accessibility. You know, like if your eyesight is bad, you can ask the app to read aloud text or to magnify your text. Now, inherently, accessibility service needs to get access to your apps, because you don't want each app to have its own accessibility settings, you know, that to read aloud text or magnify it or so. So you have one app that accesses all the other apps and reads their text. And sometimes you want it to like click buttons for you, because you can't see the button. So it has higher permissions to do stuff. Now, basically, the accessibility service, how does it work? There are some events called accessibility events, which it can listen to and perform actions based on them, basically. All you have to do is implement this abstract class and extend its methods, and everything's going to be fine. Now, are you ready to write some malware? I'm going to show you how to use these concepts to create an accessibility service malware that does credential stuffing. Just disclaimer, don't try this at home, please, okay? That's not cool, right? The first thing we want to have is to create an accessibility service. Now, this is done in the manifest, okay? You simply need to request the bind accessibility service permissions. Do I have to explain more about manifest? I assume you're familiar with it, right? Great. Okay. Next thing we have to do is to actually implement the service. Note that we use specific parameters here to get all the accessibility events and to get all the apps, so we don't miss anything. Now, what we want to do is, when our service starts, we want to launch our victim app. How we get the name of our victim app? We can go to the manifest of that app, and then we can get the name of the main activity, right? It's pretty easy to do. You don't need special permissions for this, just sorry, I'm a bit excited. You just start the app from our service. Once you start the app, we need to find the login button. Why? Because we want to do credential stuffing, and for that we need to try to login attempts. We attempt to log in many times. So, wait a minute. What we did here is we implemented the onAccessibility event function, which is the event handler for accessibility events. Basically, when our app opened, we got an event that says, hey, an app was opened. Now, we're going to make sure that this is our app, and then we can find the relevant button. Now, how do we do that? Accessibility services get something called an accessibility node tree. That's basically a tree of all the UI elements that's relevant for us. The button is here somewhere. In this case, it's probably in the sub-container of the lower row. You see the cart button there. So all you have to do is to iterate over this node tree until we get the button. In our case, we can discover that this button is called a cart button, which is an indicative name. And then you can press it. It's really simple. There's a function called perform action that you can use to click the button. Now, what did we do here? We opened our app. When you open the app, we got an event that says, hey, a window was changed. Then we used that event to press the button, which caused an event that, hey, the screen was changed, the content changed, look. We just changed our event that's called accessibility event chaining. Basically, whatever our accessibility service does causes more events to trigger, which fuels itself. That's very powerful. Questions before I'm continuing? Right. Yeah.
So my understanding of like the accessibility, does the customer have to have accessibility set up in their app, or does it automatically scrape the view model?
As far as I know, that's automatic.
Okay.
Like the service should work with any apps, right? Now, if you have an app, you want the accessibility service to work for you, right? So it should construct it from the Android stuff. I'm not 100% sure how that works because I'm not developing apps myself, but it should work.
It seems like the accessibility framework automatically scrapes whatever is viewing on the screen. And then if you tap onto that, it's like a tap, but for the view model. And then if you have information on that, it's basically just an HTML page, right? Is that right?
Yeah. Note that anyway, most apps all popular apps are vulnerable to this. You know, that's the example here shows an app that I downloaded from GitHub, you know, but you can do this on like every popular app that you can imagine that doesn't have protections against this. Okay, so I'll continue. We're here. All right, we got to this screen, and now what we want to do is to enter our login details. That's very simple. All you have to do is to look for the text boxes, enter our username and password, then click the login button. Simple. All of that was really very simple. Despite Android claiming to not let you do things like that, an accessibility service is like the magic password, and you can do everything. When I tested that, I got 5 to 7 login attempts per second, depending on the device. Now imagine if you have 1,000 devices running, that's like about 6,000 login attempts per second. That's pretty big. And each login attempt is a chance to get an account that you can sell for money. Note that this is not a one-trick pony. What happens here that we created a malware for a specific app. You can also create a generic malware which can target any application, just like the ATS malware from the start did. All we have to do is to set up our C2 server, which basically we'll send from the malware to the server, we'll send a list of running apps on the device. And then the server will say, I want to target this, this, and this. And on this app, you need to press these buttons, write this stuff, and go to this view. And this is what the app will do. All right? So that's very powerful. Now, you might notice a problem. Everything we did, it's visible, right? The user can see what we did. So we're going to hide our malware from the user. So the user doesn't know they're being targeted. The most simple way we're going to use is we're going to detect if the phone is faced up or down. Now, imagine like this. You're going to eat with your friends. You take your phone out of your pocket and place it like this on the table, right? Most of you probably did it a few times. Now, once we do this, the orientation sensor senses that the phone has been turned upside down, and our app can begin to run. The user won't see anything because the phone is upside down. Once we turn the phone face up again, we'll just click the home button, and the user won't know that anything happened. Now, this can be combined with another thing called the wake lock API. That's basically another permission that you can use to make the device stay awake. So I put my phone down. I think that it's going to shut down, to lock itself after a few seconds. But actually, the malware obtained the wake lock, and it's going to stay awake for all the time while it runs. Note that if the user actually presses the lock button, then the device will be locked, even if the wake lock is caught. So please, if you think your device is infected, just lock it manually. Now, another way to do this attack is like the ATS malware, where it shows an overlay, remember? So what we're going to do you know this thing where you log into an app, and then you get this annoying loading screen for a few seconds? Now, imagine. You try to log in. You get this loading screen. This is not a real screen. It's fake. That is an overlay. Underneath it, our malware just runs for, let's say, 2, 3, 5 seconds. Okay? Now, 2 to 3 seconds of login attempts times 5 to 7 login attempts per second, that's an easy 10 to 20 login attempts each time you try to log in. And that's not even noticeable. Like how many times a day you get a loading screen for 2 to 3 seconds, it's nothing. And so our malware is not easily detected. To summarize, what we did is we infected multiple devices. Since every device is legit, then we can try to perform login attempts from the devices for a distributed credential stuffing attack. Then we created our malware, which is basically doing the attack by its own. Then we match combos from a combo list, and we sell them for money. Okay. I'll remind you again, please don't do this at home, okay? Even though it's nice, it's illegal, so no. Okay. A few words about AppDom. As I said, I'm a researcher at AppDom. What we do is we protect mobile apps from threats like this, like distributed credential stuffing, like accessibility service malware, and many other threats. Here's my mail and the website. And if any of you have any questions, now is the time.